Artificial intelligence, or AI, refers to computer systems that are designed to perform tasks which typically require human intelligence. Unlike traditional software that follows explicit instructions, AI systems can learn from data, recognize patterns, and even make decisions with varying degrees of autonomy. But how? Here's a quick explanation of how AI works behind the scenes. First, training on text. A large language model is trained on vast amounts of text from books, websites, articles, and other written material. Anything it can get its virtual hands on in the public domain. This helps the AI learn the patterns and structures of language, such as grammar, vocabulary, and even the typical context in which words are used. Second is understanding patterns. As the AI processes all this text, it doesn't memorize facts or specific sentences. Instead, it picks up on patterns. For example, it learns that cat often follows words like the or black or tabby, and might be associated with terms like meow or purr or hairball. Third is generating responses. When you ask the AI a question or give it a prompt, it uses its understanding of language to generate a response. It starts with the context you've provided and builds on it, thought by thought, using its knowledge of likely word sequences. In essence, AI doesn't have consciousness or understanding like a human does. Instead, it uses statistical patterns in language to understand what you're asking it to do, and then it generates responses that sound coherent and contextually appropriate. Why is that important? Well, AI is a different kind of technology than its predecessors. Excel formulas are predictable. You can tell it to add up all the values in a column or multiply two values together, and that's what it will do every time. In Word or Google Sheets, you can change a font size, increasing it in predictable amounts. Even sending an email was a new technology once, but once again, it's predictable. You enter the recipient's address, type what you want it to say, and send it. But AI works differently. You can ask AI, how can I make the tastiest pancakes in the world 100 times and get 100 different recipes? It's not a copy and paste machine, but that isn't a bad thing at all. It's how AI is supposed to work, and it's why it's important to learn enough about AI to make it work for you. Look at what AI can do and what it can't. AI can improve efficiencies and workflows, connect to certain software with your permission, and free up some of your time to focus on strategic or creative projects. AI can't read your mind, do everything you want it to do exactly right on the first try, or magically access everything on your computer. Let's go over some essential terminology you'll encounter in this course and when using AI. An AI model is a specific program or algorithm trained to perform particular tasks. Think of it as the brain that powers AI tools, like the HATS AI chat or automations or workflows. Models vary widely in their design, capabilities, and the types of problems that they solve. When we say AI, this is usually what we're talking about. Large language models, or LLMs, are sophisticated AI systems that are trained on vast amounts of text data. They can generate human-like text, answer questions, translate languages, and even complete many language-related tasks. ChatGPT is an example of an LLM. Sometimes, AI, AI model, and LLM are used interchangeably, so don't get hung up on the technicalities. Reasoning models are a type of LLM designed to perform complex reasoning tasks by engaging in a chain of thought process, revealing intermediate steps and thought processes before arriving at a solution. AI is often eager to give you a quick answer, so reasoning models are intentionally slower so that they can give better, more accurate answers. It's almost like they take your prompt, rewrite it to be the optimal input for the AI model, and then generate the response step by step. You might say they're smarter or more intelligent, but really they're just taking more time to think through what you're asking them to do. Training data is the information used to teach a model to recognize patterns, make predictions, or perform tasks, essentially acting as the foundation for its learning and ability to make decisions. Models' training data have cutoff dates, the date the model stopped learning from new data. If you ask different models what day it is, They'll usually tell you the last day they had access to real-time data. This will be important later. A neural network is a computing system inspired by the human's brain structure. It consists of interconnected nodes or neurons organized in layers that process information. Neural networks excel at recognizing complex patterns and are foundational to many modern AI systems. They're designed to work the way human brains work, which makes it easy for humans to interact with AI, which leads us to natural language processing, or NLP, which enables the AI to understand, interpret, and generate human language. What this means for you is that you can interact with AI in a no-code environment. Just talk to it like a coworker, or better yet, talk to it like an infinitely patient intern. Prompts are what you use to talk to AI. They're the inputs you provide to a model to elicit specific responses, ranging from simple questions to complex instructions, or in some cases, files and images, and good prompts significantly increase the quality and relevance of the AI's output. Tools are external features that the AI can access through something called tool calling. Some examples include searching the web, where you can give AI access to the internet, or CRMs, where you can give AI access to Salesforce or HubSpot to ingest information and update it. There are hundreds of tools out there, and we'll cover more in a later section. AI adoption is the ongoing process of incorporating AI tools like automations, workflows, and agents into your organization. Because AI is always evolving, your AI adoption strategy should never end. Let's look at a brief history of AI. Artificial intelligence has a longer history than you might realize. The concept dates back to the 1950s, when computer scientists first began exploring whether machines could think. In 1956, the field was formally established at the Dartmouth Conference, where the term artificial intelligence was first coined. Early AI research focused on rules-based systems where humans explicitly programmed logical rules for computers to follow. The 1980s brought us expert systems, programs designed to mimic human experts in specific domains. And while useful, these systems couldn't learn or adapt to new information independently from their programmers. The 1980s also brought us a new wave of AI in pop culture, with movie franchises like Alien, Terminator, and Blade Runner, and even Star Wars. Unlike those AI-powered antagonists, the AI today we have is very much a net positive influence. Machine learning began gaining traction in the 1990s, with algorithms that could improve through data exposure rather than through explicit programming. Machine learning is a subset of AI where systems improve automatically through experience. So rather than being explicitly programmed for every scenario, machine learning algorithms use data to identify patterns and make increasingly accurate predictions or decisions over time. In 1999, director Peter Jackson was an early adopter who brought AI to the silver screen with The Lord of the Rings. Many of the large-scale battles in the films used AI-generated characters to play out combat scenes. Since then, many studios have opted for AI-augmented CGI rather than the logistical nightmare of hiring, training, costuming, and choreographing tens of thousands of paid extras. A significant AI breakthrough came in the early 2010s, with deep learning and neural networks becoming practical thanks to increased computing power and larger datasets. Since then, we've seen unprecedented advances in language models, with the development of increasingly sophisticated large language models, from early versions like BERT to more recent models like ChatGPT, Claude, and Grok. These systems can now generate coherent text, translate languages, write code better than most humans, and engage in conversation that wasn't possible just a few years ago. Today's AI landscape that we're focused on is dominated by these LLMs that can be adapted to thousands of business applications, from customer service to content creation to data analysis, tools that are increasingly accessible to businesses of all sizes. LLMs are becoming household names. They're everywhere. This study from early 2015 shows that the length of tasks that AI can complete has greatly increased since 2023. If this pace holds, AI will soon be able to complete an entire month's worth of work that a human is now doing. Let's talk about security. AI models get better over time because they gain access to more data. If you're using free AI tools, Do you know how your data is being used? Do you know that uploading confidential or proprietary information into a free AI tool means that the AI tool is learning from your data? Remember, if you're using a free AI tool, they're making money somehow, and that's probably through the use of your data. Data security should be a foundational consideration, and not an afterthought. The reality is that your employees are likely already using AI with or without your knowledge. Can you say for sure that your company's sensitive information isn't being uploaded into free and open AI tools and used to train their LLMs? If your company's data or your customers' data is used to train large language models, it is accessible by other users, which can lead to loss of intellectual property or exposure of confidential information. Additionally, letting your team use their own personal AI accounts for business can make it virtually impossible for you to ensure that sensitive data stays with the company when an employee leaves. If you're using HATS AI, you can rest easy. HATS was built from the ground up with cybersecurity and data privacy in mind. We have built our platform to take these security risks very seriously. You can find out more info at trust.hats.ai. It's crucial to know the risks of free and open AI tools before you jump headfirst into adoption. And to be even clearer, if you're using HATS AI, you're already ahead. Bias in AI. Beyond simply addressing security and data privacy risks, once you start using AI, you need to be aware of some other concerns. The vast majority of these concerns can be mitigated through prompt engineering and through advancements of the LLMs themselves. But it's important to know that not everything AI tells you is factually true or accurate. This is because of something called bias. Bias in the context of AI and data refers to a systematic error or prejudice in the model's predictions that lead to unfair outcomes or decisions. This can occur due to flawed data, assumptions in model design, or societal prejudices that are inadvertently coded into the algorithms. Biases can result in some groups being favored over others, leading to unequal treatment. Representation bias occurs when certain groups are underrepresented in training data. For example, facial recognition systems trained primarily on light-skinned faces have shown higher error rates for darker-skinned individuals, particularly women. Some studies have shown that early AI models would almost always describe doctors as men and nurses as women, which is an inaccurate and sexist stereotype. Measurement bias happens when chosen metrics fail to capture important aspects of what we're trying to measure. For instance, using historical hiring data to train AI recruiting tools may perpetuate past discrimination patterns rather than identifying the best candidates. If you show the AI resumes of the last 50 hires as examples, and they all happen to be men, AI might assume you only hire men and discard the other candidates if they believe they aren't men. Aggregation bias arises when models are applied across different populations without accounting for important differences between groups. A medical AI trained on the general population might perform poorly for specific demographic groups with different disease manifestations. For example, a cardiovascular risk prediction algorithm trained primarily on data from middle-aged white patients might miss important factors when deployed in a hospital serving a diverse population. And these aren't just hypotheticals. The real-world impacts of these biases can include qualified candidates being overlooked in hiring processes, unequal access to financial services like loans or insurance, disparities in healthcare quality and outcomes, and unfair treatment in criminal justice systems. We're talking about biases in this course so that you can be aware that just because AI tells you something as a fact, it is not all-knowing and it can make mistakes. It's trained on human data after all, and human data is not always reliable all the time. But don't worry, there are ways that you can interact with AI to mitigate those mistakes, which we'll cover later in the prompt engineering section.